liftoff as the countdown to Mars continues.
It took 7 months for the Perseverance rover to travel between Earth and Mars. And once it arrives, 7 minutes to descend from the top of the atmosphere to the surface.
Well, landing on Mars is all about finding a way to stop, and stop in the right place.
When it comes to entry, descent, and landing, Al Chen is the man in the hot seat at NASA's Jet Propulsion Laboratory. It takes 11 minutes for radio signals to travel the speed of light from Earth to Mars. Too much lag time for Chen and his team to remotely pilot the rover. So Perseverance must land autonomously.
And that's kind of one of the central challenges, I think, of landing on Mars. We can't participate, we can't guide it, we can't pilot it on its own. We have to train Perseverance to do it on her own.
It all culminates with what's called the Sky Crane. Retro rockets fire on the descent stage, and the rover is winched down to the surface on tethers. It all may seem a little harebrained, but the one time NASA tried it, with the Curiosity rover in 2012, it worked like a charm. Perseverance is aiming for the Jezero crater, which may hold the answer to the big question: did life once exist on the planet next door? Lori Glaze heads NASA's Planetary Science Division.
Jezero really stood out as a potential landing site because within that crater we can see absolute evidence that there was a lake that persisted there long enough that a river flowed into that crater and deposited all of its sediments into a river delta.
The crater has been bone dry for 3.5 billion years, but in its wetter, warmer days, this place might have been a rich breeding ground for life, perhaps something resembling bacteria or algae here on Earth.
So if those early microbes were present on Mars, this is exactly the kind of deposit where they would be preserved.
What we are going to be looking for are biosignatures, the leavings of microbial life.
Geologist Ken Farley is the project scientist for the mission.
Everybody is familiar with the idea that living things are made out of organic matter, and some of that gets preserved. And the idea is that using one of the instruments on the rover, we can actually see how that organic matter is distributed.
The science team prepped for the mission in Western Australia. The rocks there are about the same age as those in the Jezero crater.
When we look at these ancient terrestrial rocks that have evidence of life in them, what we see is that microbes formed mats. These are layers at the interface between a lake or a shallow sea and the mud at the bottom. That held the sediment together and actually distorted it in very characteristic kind of mushroom-shaped patterns called stromatolites. These are a really obvious kind of biosignature. That will be something that we will be looking for very carefully with the rover.
Perseverance will drill core samples out of rocks that might contain these organic biosignatures. They will be sealed up in tubes and dropped off on the Martian surface for a future rover to collect and send back to Earth. It's a concept called sample return.
So we are so excited about Mars sample return. We are closer now than we've ever been before.
But it's still a ways off. By the time the Retriever rover launches to Mars and a sample is sent to Earth, it will likely be the early 2030s. Biosignatures are signs of possible life, but not smoking gun proof. Teasing out that question will be a lot easier in a lab here on this planet.
But when we get those samples back in the laboratory, that's what's going to give us our best opportunity to be able to say whether or not some of those molecules that we're finding were actually biologic molecules or whether they could form in other ways.
But for now, the star of this rover show may turn out to be this little 4-pound drone helicopter named Ingenuity.
It's a game changer. It's something that will enhance space exploration, period. It's the ability to fly around the planet.
Mimi Ong is the project manager on this technology demonstration experiment. They're planning 5 short test flights. Mars changes the equation for flights with wings or rotors. The gravity is about 1/3 of Earth's, and the carbon dioxide atmosphere is much thinner.
It's about 1% compared to here, right, on Earth. Even though you're able to lift, right, you have to spin very fast to lift. Because the atmosphere is so thin, you can't lift as much mass.
If successful, Ingenuity could usher in a new era of mobile exploration on Mars, a reconnaissance tool to find intriguing sites for science. And it would be a historic first flight on another planet.
It's been a long journey. I'm very goal-oriented. I want to get to learn as much as we can about flight. Think of Wright Brothers experiments, right? A whole series of experiments. At Mars, we just get to get one shot, right?
And speaking of shots, Perseverance will aim its cameras at Ingenuity when it flies. Another iconic image of a first flight awaits us. For the PBS NewsHour,